All right, guys, today we're going to talk about some basic chemistry. So, what is the chemistry that you need to understand in order to do biology? Because you are a bunch of chemicals put together to make a living organism. And all of those chemicals interact in order to make you who you are and to make you think the way that you think. So there is some chemical understanding that is necessary to understand biology. And in fact, if you were to go on into college and study bio, you're going to have to take maybe up to 2 years of chemistry. So the first thing we want to look at is atomic structure. All atoms have the same basic structure. In the center of the atom is the nucleus, which contains a proton and a neutron. And then swirling around on the outside are going to be electrons. Protons have positive charges. Neutrons are neutral, so P for positive, N for neutral. And then this electron is negative. So the electrons that are swirling around on the outside are negative. Molecules in their composition can borrow or loan or share these electrons because they like to have this outer orbit full. And there's a certain number of electrons that fit into each outer orbit, and they want their orbit full. And so to make it full, they're going to borrow or share electrons to do that. So there are multiple orbits. The first orbit has 2, and every other orbit has 8. And there it is in picture form. You have your protons and your neutrons here in the center, and your electrons swirling around on the outside. The elements are something made up of only one type of atom. So if you have carbon, it's all carbon atoms. If you have hydrogen, it's all hydrogen atoms. All elements that have been discovered are listed on a periodic table, which is what you see here. And it describes the weight of the element, the number of electrons, and gives a symbol used to describe that element. At the end of this year, if you're going on to chemistry, you're going to have some summer homework where you have to memorize some of this information. An isotope is an element that has more neutrons than what we originally thought. So we can have heavy uranium. That heavy uranium has more neutrons than regular uranium. The isotope weighs more than the original form of the element because it has extra neutrons. This isotope, though, is used the same way in chemical reactions. Your body absorbs it the same. It's done in the formation of water the same, in the formation of carbon dioxide the same. So it's being used the same, even though it is slightly different. And this slight difference we can use to age things. Radioactive isotopes are defined as isotopes that have a nucleus that's unstable. It's got more neutrons than it should have, and because of that, those neutrons aren't supposed to be there and it breaks down. Over time, the neutrons are released into the environment as your isotope goes back to the way it should be, to its normal form. The breakdown of the isotope occurs at a constant rate. It is mathematical, it is predictable, it is constant. This rate can be used to date fossils by comparing the concentrations of radioactive isotopes in the fossil to the concentration found in the current environment. Radiation can be used for good or for evil. It can cause cancer and life-threatening diseases, but on the flip side, we can use it to cure cancer. A compound is more than one element joined together with a bond, and there are 3 different types of bonds that we're going to talk about. The chemical properties of the compound are often very different than the individual element. So for example, you're looking at a water molecule here, and it's made up of oxygen and hydrogen. Individually, oxygen, when it's by itself, highly flammable. Individually, hydrogen, when it's by itself, highly flammable. But when it comes together into a compound form as water, you can use it to put out fire. All right, our types of bonds. The weakest of all bonds is a hydrogen bond. This is created by the attraction of a negative ion to a positive ion. So you've heard that phrase, opposites attract. Well, a thing that is negative wants to hang out with a thing that's positive. And that wanting to hang out together is a hydrogen bond. You're not sharing anything, you haven't loaned anything, you're just like, hey, I'm slightly attracted to you. And if that attraction fades, then they're just going to disassociate. They're going to go their separate ways. So a hydrogen bond, easy to form, easy to break. An ionic bond now is the next in our strength. So hydrogen's the weakest, ionic is the middle ground. It's formed when two or more electrons are transferred from one atom to another. The atom that loses the electron has a positive charge, and the atom that gains the electron has a negative charge. These atoms are then referred to as ions. The opposite charge of the ions forms a strong attraction. Let me put it this way, right? You've got your iPhone, and someone walks up to you and says, dude, I lost my phone. Can I make a quick phone call on yours? And so you hand them your phone. Are you going to go far away, or are you going to stick pretty close to the person that's got your $600 phone in their hands? You're going to stick close, right? So that's your bond. The same thing's going here with ionic bonds. One atom has loaned its electrons to someone else. It eventually wants them back. So it's going to hang out close to the one that it loaned to. And here's just it in pictorial form. All right, covalent bonds, strongest of all bonds, because they're actually sharing the electrons. When covalent bonds are formed between two elements, the resulting compound is now called a molecule. Because it's such a strong bond, these things are together for the long haul. And so we're going to call it a molecule. This is like when you're back pre-COVID times and you're sitting next to someone in class and you're sharing earphones, right? Where you've got one in your ear and someone else has got the other one in their ear. You guys can't go far because you're sharing something that is physically attached. Stronger and harder to break to any bond, and most of the bonds in your body are covalent bonds. So here's a covalent bond, they're sharing. Here's ionic bond, they're loaning. Okay, water. Water is the universal solvent. Most things will dissolve in it if left for a long enough time. And it's unique because it exists in 3 different stages on Earth. So ice as a solid, water as a liquid, water vapor as a gas. But it's all still water. It has the ability to bond and dissolve most things due to the polarity, that strong positive and the strong negative ends. Positive charge on one end, negative on the other. The covalent bonds between the hydrogen and the oxygen prevent water itself from breaking apart. We call water the universal homewrecker because when you add water to something, you're gonna break it apart. You are mostly water, and life on Earth as we know it would not exist without water. And that's why when we go to other planets like Mars, we look for water. Water has a bunch of properties that you're going to investigate in your lab. It has transparency. It's invisible, like things can go through it. Your eye has water in it so you can see through it. Water has cohesion and adhesion, the ability to bond to itself and to other things. And it has a strong capacity to absorb heat. And so as it absorbs heat, it takes a lot longer to break the bonds using heat. And so it sucks the heat in. And you're going to see that on a graph. Mixtures, 2 or more substances mixed together but not chemically bonded. An example is salt and pepper. All the materials are evenly distributed through the area, and you can separate them because the compounds remain intact. Solutions, the materials are undergoing physical but not chemical change. One thing gets dissolved into something else. So the solvent is the thing doing the dissolving, and the solute is the thing being dissolved. Best type of mixture. The individual parts cannot be seen underneath a microscope, and it's hard to separate them. They can be split apart and release their individual ions. So when you guys do your lab, you're going to take salt and mix it into water. Well, how do you get the salt out of the water? You basically let the water dry out, and the salt is left behind. We do have acids as solutions, and these release hydrogens. It's the most chemically reactive known ion, and it attacks other chemical bonds. Bases are the opposite. They release hydroxides. pH is the measurement of hydrogens and hydroxides in a solution. And when you look at pH, things that are acidic are below 7 on the scale. Things that are basic are above 7 on the scale, and 7 is neutral. A suspension is materials that don't mix, but instead one floats on top of another. So when you see the image here, that's oil and water, and the oil is too light to sink into the water. Blood is a type of suspension, so the red blood cells are suspended in the plasma. All right, that is the end of lecture. Next up is a lab to play with water to look at those properties that we talked about.